Okay, so when we have speed over here, let's say, not the position, speed meter per second. So this shows constant velocity, a straight line. This is also a constant velocity graph, okay? But what is the difference between this velocity and that velocity?
That the first one and the second one.
Yes, what is the difference between these two?
In the first one, the velocity is increasing.
And the second one also, the velocity is increasing, but what's the difference? Yes.
Oh, that the first one starts at 0 and the second one is not.
Okay, let's say this is also starting from 0. Then what will be the difference?
Uh,
Can you see that the change in its speed is more over here as compared to here with respect to time?
how?
This graph is going up, okay? Producing in this particular time, it is producing this much of change. While in this graph, the change is only this with respect to time, isn't it? Did you get
But
it?
yes, yeah.
This change is low in this graph and this change is high in this graph. The steeper the
How?
graph is, the steeper means this. The steeper the graph is, the greater will be the change in the speed.
Why are they saying leftward and rightward?
Do not concentrate on this. Just ignore this. Okay?
Okay.
Just ignore these words. Just remember the shape of the curve. If it is a straight line, then it is a constant velocity graph. If the graph is towards downwards, that means it is also a constant velocity graph, but the change produced or simply the value of velocity will be very low. Okay. Basically, it is not a constant velocity graph. When it comes for the speed time graph, it's a constant acceleration graph. Okay. When we are talking about speed time graph, then a straight line represents a constant acceleration. Okay. Here also we have a constant acceleration if the graph starts from 0, but the change in acceleration is very low. Clear?
Yes.
Make sure that these all graphs are basically between the stationing is basically the here the change is very low. Clear?
Yes.
Okay, now let's come to the next portion of the graph. Again, all the graphs are between speed and time. So we are observing the acceleration. In this particular point, the acceleration is increasing. Also, the speed is increasing. So when it comes in the question, describe this portion of the graph. Or suppose if it is asked, describe this
The
graph
rating.
from A to B and then B to C. How you will do the how you will write the description? A to B, we have a constant acceleration because there is a straight line. And from B to C, we have a non-uniform acceleration and it is an increasing acceleration. They will not give you marks only on the word non-uniform acceleration. They will give you the marks on the word increasing acceleration. Okay.
Okay.
Similarly, if the graph is like this curve, it is a decreasing acceleration. Okay.
Yes.
The acceleration is non-uniform and it is decreasing. Okay. But if it is decreasing in the downward direction like this, then we are entering into the term deceleration. Clear?
Yes.
This graph and this graph, then this downward curve is increased deceleration. The change in acceleration or deceleration is very low over here. Is that clear
Yes.
to you? This is how you will define the graphs.
Yes.
Clear? Okay, now how to draw a tangent on the graph it comes for suppose. Can you see the screen? In this particular graph, they are asking first of all to define the motion. Write the letter P1, point where the ball accelerates. Where the ball accelerates. Okay, always remember that whenever the graph type of question comes, always check it out the axis. Whether it is velocity written, speed written, or distance written. If it is a distance time graph, always remember for a distance time graph, if we are getting a curve like this, it means we are having an acceleration. Okay.
Yeah. Okay.
So the 2 points on which the point on which the ball is accelerating, there are 2 points actually, this point and that point. So they are asking to mark only 1 point. So they have marked P over here. Okay.
Yes.
And then they are asking 1 point where the ball has a constant speed. So this is a constant speed graph. Okay.
Where? I don't. Oh, okay. Okay.
This
Okay.
portion, this straight portion. Okay.
Okay.
Is that clear?
Yes.
Is that clear to you?
Yes.
Now, in the next part, it is not mentioned in the particular picture, but the next part was draw the tangent on X and find out the value of speed. So how you will draw the tangent? On point X, we will draw this straight line and we will select any 2 random points. Like this will give you time. So that will be your T2 and this will be your distance 2. Okay. Then we will select this point, that is random. You can select this point as well as this point as well. Okay. So that will be D1 and that will be T1. So this is similar to Y2 minus Y1 over X2 minus X1. So with the help of this, you can get the value of speed or velocity. Clear? Because you are subtracting 2 distances and 2 times. So distance upon time will give you the speed or velocity. Always remember when they are asking to calculate the speed or acceleration from the curve, always draw a tangent on the curve because gradient is always calculated for the straight line, not for the curves. That's why we are drawing tangent. Okay. And if they are asking to calculate the acceleration of the graph, that is a straight line, just select any 2 points, take the difference like this and get the value. Clear?
But gradient equals to y2 minus 1. It's not acceleration.
Here the graph is distance and time, right? So when you get the value of distances over here and when you get the value of time over here, so distance upon time is basically the formula of speed. That is why I'm continuously saying that do check this y-axis. If there is speed written, then this will become V2 minus V1 over T2 minus T1. So this will give you acceleration because change in velocity with respect to time is acceleration. Clear?
Yes.
Did you get it? Just be careful about the graph that what is written on x-axis or on what is written on y-axis. Okay. If the graph is between distance and time, you will be calculating speed. If the graph is in between speed or velocity or between time, then you will be calculating acceleration. Clear?
Yes.
Now, what is a terminal velocity? When we are dealing with terminal velocity, we always are dealing with the vertical motion. So for the vertical motion, only there are 2 forces that is acting on the object or on the parachutist. That is air resistance and the weight. Weight is acting downward, air resistance is acting in the upward direction. When both the forces get balanced, we will be getting resultant force 0. And on that resultant force, always remember the acceleration is 0. And whenever the acceleration is 0, always remember that speed that is coming out is always a constant speed. Always remember that this terminal velocity is only observed on vertical motion, not on horizontal motion. Okay? Is that clear?
Yes.
So when the parachutist jumps from the aeroplane, what will happen? He will first accelerate. That means weight is greater than the parachutist. At this at constant speed, possesses zero resultant force, zero acceleration, and that velocity is known as terminal velocity. Clear?
Yes.
Okay. Then at this point, he will open his parachute. When he opens his parachute, what will happen? The surface area of the parachute increases, due to which suddenly the air resistance increases. That means the upward force increases. So he will start moving upward instead of downwards. Okay. So when he start moving upward, he will decelerate drastically. Okay. So this is a deceleration
Yes.
graph. At this point, again, weight will overcome the air resistance and becomes equal with the air resistance. And again, we will be getting a resultant force 0, acceleration 0, and we will get a terminal velocity again. Clear?
Yes.
Any confusion in this thing? Always remember that when the object is dropped from a certain height, the downward motion always possesses acceleration. When the object is raised to a certain height, that means when we are throwing ball in the upward direction, that means that ball will be accelerating. The upward motion will be acceleration, the downward motion will be deceleration. For suppose a lift is going from first floor to the ground floor, then the lift will be accelerating. If the lift is moving from first floor to the 8th floor, then the lift will be decelerating. Clear?
Yes.
Any confusion?
No.
Sure?
Yeah.
Now let's talk about forces. When we are talking about vertical motion, always remember that for suppose if the rocket motion we have or the aeroplane motion we have, the engine force is known as the thrust force. So if this aeroplane is moving in the forward direction, you will write that aeroplane is moving with greater thrust force. Okay. And the force that is basically giving a counter effect on this thrust force is the drag force due to air resistance. Okay.
Yes.
So drag and thrust, they are basically getting balanced or disbalanced when the aeroplane is moving. Okay.
Yes. Okay.
Okay. Let's talk about the horizontal motion. For horizontal motion, if the car is moving in the forward direction, then that car is again moving with its engine force, and that engine force or the forward force is known as the driving force. Okay.
Yes.
A swimmer is moving in the forward direction in the water, that is also the driving force of the swimmer. Okay. The drag that it is facing, that car is facing, is the frictional force. So that frictional force is drag force. So just use these words. These are the keywords. Okay. So if this force is greater than that force, that means if the drive is greater than the drag force, the car will accelerate in the forward direction. So there will be acceleration. Okay. In that case, you can calculate the formula of resultant. You can use formula resultant force is equals to mass into acceleration. Okay.
Yes.
And how you will calculate this resultant force? If this force is given, then it is fine. If this is not given and driving force and drag force is given, then you can first calculate the resultant force by subtracting drive minus drag. When you'll get the value from here, you will just put the value of this force over here. If for suppose mass is given to you and they're asking to calculate the acceleration, now you can calculate the resultant force with the help of the formula mass into acceleration. Clear?
Yes.
Okay, this condition is Newton's second law. When we have resultant force is equals to mass into acceleration, and the car is will be greater than, so in that case the car will be accelerating, and you can also calculate the resultant force. Can you see the screen again?
Yes. No. Yeah, I can.
So here, if you want to calculate the resultant force, here the drag is greater than the drive. So drag minus drive will give you the resultant force. And with the help of this formula, you can either calculate the mass or deceleration. Okay.
Yes.
Okay. Now let's talk about the resultant force when it is zero. When resultant force is zero, it means that both the forces are equal to each other. At this condition, the resultant force will be zero, the acceleration will be zero, and the object will move with constant velocity. So whenever it comes to write down the conditions or write down the motion in which the object is moving with constant velocity, you have to use these terms, that the acceleration will be zero and resultant force acting on the object will be zero when the object is moving with constant velocity. Clear? Now in that
Yes.
case, there will be no acceleration, so you will not use this formula. Okay, because this
Yes.
is zero and this is also zero. Clear?
Yes.
Any confusion up till here?
No.
Okay. Now let's talk about momentum. Okay, always be careful about the units. The unit of force is Newton. Velocity is meter per second. I have provided you the formula sheet as well, right?
Yes.
Okay. And acceleration is meter per second square. Okay. Try to convert all the units into SI units. Your first job will be to convert all the units into SI units, okay, in order to be at the safe side. So what is the definition of momentum? It is simply defined as the product of mass and velocity. Okay. Let's say there are two objects. One is a ball and one this is a truck. When they are moving, if I want you to calculate the momentum of this and this, so that momentum will be the before collision momentum. Okay.
Okay.
Okay. And before collision momentum means you will add up the momentum of ball and truck both together. Clear?
Yes.
So you will just multiply the mass and velocity of the ball and put the value over here. Mass and velocity of the truck and put the value over here. Okay. When they both collide, one will move in the opposite direction, the other will move in the opposite direction. Okay. Obviously, truck is heavier, so we will take its velocity as positive, and ball is less heavier, so we'll take its velocity as negative. Okay. So after collision, also the mass will remain the same. Let's say this truck will move with a velocity of now after the collision with 7.5 meter per second, and this move for suppose with a velocity of 1.5 meter per second. Now, how you will calculate the after collision momentum? Obviously, in after collision, again, you will add up the momentums of both ball and truck. And because ball is moving in the opposite direction and it is lighter, that's why we are taking a negative sign over here. So how now you will calculate the after collision momentum? Yes.
Can you repeat your question?
How you will calculate the after collision momentum?
After collision equals to before collision?
But after collision momentum, the total momentum. I'm asking for the total momentum. How you will calculate it? The mass is given and the velocity of ball is given after the collision. And the mass of the truck is given and the velocity of the truck is given.
Mass multiply velocity?
Yes. So this mass will be multiplied by this velocity and this mass will be now multiplied with this velocity. Clear?
Yes.
Is that clear? So that's how you will calculate the after collision momentum when the two objects are moving in the opposite direction after the collision. Clear? So
Yes.
they'll give you the question like, for suppose, if I am doing an amendment in the question, let's say this velocity is not known. The question is, calculate the velocity of the ball after collision, and velocity of the truck after collision is given, it is 7.5 meter per second. So what your strategy is, you will first calculate the before collision momentum by the given information. Just calculate it and tell me the answer quickly. Do it quickly, okay?
I'll do 0.5 multiplied by 5.
Yes, that will be for ball, which will be added into the truck.
It's 2.5.
Okay, it's 2.5. Let's write it step by step. So this is 2.5 and the unit will be Newton second or it will be kilogram meter per second, okay? What is the velocity of the truck? Sorry, momentum of the truck?
It's 16,000.
So when you add up both the
There's another 0.
momentums, okay, when you add up both the momentums, what answer you will get? It will be, what will be the answer?
It will be 16002.5.
This is the answer?
Only, no, without another 0. It's only 2 zeros.
So this is your answer, right? This thing that you have calculated is basically before collision, okay? Now, you need to find out the velocity of this ball after collision. So for after collision, the velocity of the truck is given. Now do the calculation for after collision and find out the value of velocity after collision by using the law of conservation of momentum that states that before collision momentum is equals to after collision momentum. So how you will do it?
M1 by V1.
How you will do it? First of all, calculate the after collision velocity momentum of ball. Yes.
We will do the mass of the ball multiplied by the velocity.
Multiply by velocity, which is unknown.
Yeah, and then we will do equals to mass of the truck multiply the velocity.
Plus, you will plus it, okay? For after
Plus
collision, you'll do the You will do the same thing like you have done for before collision. You'll do the same thing for after collision. You will add
Mm,
up the momentum of ball with the truck, but for momentum of ball, you will put a negative sign because it is moving in the opposite direction. Is that clear?
yeah.
So that will be 0.15 multiplied by v with a negative sign, plus truck's velocity will be 2000 multiplied by 7.5. Got it?
Wait.
Truck's moment. Okay, I am restarting the class.
Okay.